Hello, can everybody hear me? Okay, so let's get started today. So today we're gonna learn bit string flicking. So let's get started. So today I'll teach you bitwise operators, shift operators, and order of precedence. Okay, so let's start. So bitwise operators. So bits are basically just zeros and ones. And so, oh, I'm Bai Xuan and I'll be the teacher today. And I'm a 10th grader at Troy High School. Okay, so let's continue. Okay, so bitwise operators are basically operations that you can do with bits. So the operators that we're gonna be learning for the bit string flicking are not and, or, and XOR. So these are the four operators that we're gonna use in our bit string flicking. So for not, it's pretty straightforward. So not, if you enter a 0, then it will give a 1, and if you enter 1, it'll give a 0. It's like the opposite. And then for and, it will return a 1 when there's two ones. So if there's a 0 and a 0, it will return a 0. If it's a 0 and a 1, it'll return a 0. And if it's a 1 and a 0, it'll also return a 0. And it'll only return a 1 if it's a 1 and a 1. And then for or, it will return a 0 if they're both zeros, but anything else it will return a 1 because there's an or. So it can be one of them has to be 1. So when there's 0 and a 1, it'll return a 1. When it's a 1 and a 0, it'll return a 1. And when it's a 1 and a 1, it'll return a 1. And then for X or, it's exclusive or. So that means that it has to be a 0 and a 1. So for example, here, if it's a 0 and a 0, it'll return a 0. But if it's a 0 and a 1, or if it's a 1 and a 0, it'll return a 1 because it's exclusively a 1 and a 0. And if it's a 1 and a 1, it will return a 0. So are there any questions about the bitwise operators? No. Okay, so we'll continue. So these are the shift operators. So basically what they do is it will like move a string around. So for example, L shift, it will, if you have a string, it will move it towards the left. So here, where we have 0, 1, 1, 0, 1, whenever it shifts it to the left twice, it gets rid of the two most left turn bits, and it will turn it into 1, 0, 1. But we still want to keep the length of the string the same, so they'll add 2 zeros at the end. And then for right shift, it's the other way. So if it's like right shift 3, it will be from 0, 1, 1, 0, 1. It will move to the right 3. So it'll delete the right 3 digits, and these 2 digits will become the rightermost digits, and they'll add 3 to the front. So 0, 0, 0, 0, 1. And then for left circle, it will actually rotate it, and it won't just replace it with zeros. So for example, with left circle 3 of 0, 1, 1, 0, 1, they'll move everything to the left 3. So they're removing these 3, and then the 0 and the 1 will become the lefternmost digits, but then the 0, 1, 1 will be added back at the end, like this. See, like right here, the 0 and the 1 moves the most to the left, and then they add 0, 1, 1 at the end. And then for right circular, it's the other way. So if we were to do right circular 1 for 0, 1, 1, 0, 1, they would delete the 1 at the end, and then they would add it to the front. So are there any questions about this? No questions? Okay. So then we'll talk about order of precedence. So let's go to the next slide. So the order of precedence from highest to lowest. So when we do these operations, it's kind of like order of operations like PEMDAS, right? You do parentheses, then exponents, then multiplication and division are the same from left to right, and then it's addition and subtraction from left to right. So there's also an order of precedence for bit string flicking. Sorry. So the one of highest precedence, the one you will do first is not. So not comes first, and then the next two that come together like multiplication and division, for example, from left to right is shift and circle. These two are the next highest precedence. And then the next one is and then XOR, and then OR when you're so are there any questions for the order of precedence? No. Okay, so then this is all you basically need to know about bit string flicking. So now we can move on to some questions. Okay, so can everybody try to do this problem? So we want to evaluate this equation, basically, this expression. So first I'll like show an example of how to do it. So how you do this is first we have to follow order of operations, right? And with order of operations, we technically follow the parentheses first. So we'll do this one first. So 0, 1, 1, 1 or 0, 0, 1, 0, 1. So we basically compare each bit by bit. So we'll compare this one with the first bit of each, and then the two second ones, and the third one, and then the fourth ones, and then the fifth ones. So so 0 and so first let's do an OR of 0 and 0. An OR of 0 and a 0 will return a 0, right? So the first digit of this expression will be 0. And then 1 or 0, remember, or it will return if any of the like parts of any of the bits are 1. So then it will be 1. We'll put 1 for or for 1 and 0, right? And then the next one will be or for 1 and 1, which will also return 1, because as long as any of the bits are 1, it will return 1. And then 1 and 0 is 1 again, and 1 and 1 is 1 again, right? So then we have then we put this into this expression. So it will be 0, 0, 1, 0, 0, or 1, 0, 1, 0, 0, and not this one. So next we follow order of operations, and remember not comes first. So we're gonna do not 0, 1, 1, 1, 1, right? So then we're gonna like go to the opposite of each, right? So it'll be 1, 0, 0, 0, right? For not. And then it will be, we'll add this back into the original expression. So it'll be 0, 0, 1, 0, 0, or 1, 0, 1, 0, 0, and 1, 0, 0, 0. Okay, and then, so let's keep going. Okay, so then, remember we go and comes for or, so we're gonna do the and first, because remember when we go back in the slides, the order of precedence is not shift and circ, and then XOR, and then OR. So OR comes last, so we're gonna do AND first. So then it'll be 0, 0, 1, 0, 0, or remember, AND only returns 1 if both of the digits are 1. So when we compare the first of each, these two are 1, so it'll be 1. And these two are 0, so then it can't be, it has to return 0. And we notice that the rest of the digits on this string are all 0. So then we know for AND, as long as there's a 0, it'll return 0. So we can assume that there will be a 1, 0, 0, 0. So then we compare OR of these two, and it'll be for OR, it returns 1 as long as one of the digits is 1. So it'll be 1, 0, 1, 0, 0. So that'll be the answer to this question. Are there any questions? No? Okay. So let's keep going. Yeah, the answer is 1, 0, 0, 0, 0. Oh no, the answer is not 1, 0, 0, 0. Because remember it was OR 1, 0, 0, 0, or I think, yeah, 0, 0, 1, 0, 0. And remember, OR returns a 1 as long as at least one of the digits is 1. So when we compare these, when we do this expression, 1 we compare with 0, right? So it'll be 1. And then we compare 0 with 0, and this one is 0. And then we compare 0 with 1, and this one is 1, remember? Because an OR will return a 1 as long as one of the parts is 1. And then the last two are both 0, so then it'll be 0, 0. So that's, yeah, the answer is 1, 0, 1, 0, 0. Okay. So let's keep going to the next question. So evaluate left circle to 0, 1, 1, 0, 0, and not 1, 1, 0, 1, 0, or right shift 1, 0, 1, 1, 0, 0. Okay, so we go from left to right if there's ones of equal precedence, and the one of highest precedence right now is not. So we have to do the not first. So it will be left circle left circle to 0, 1, 1, 0. And what will be the not of this part? Remember, not is opposite. Does anyone know what the not will return? No? Okay. So the not will return not 1, 1, 0, 1, 0. So not, remember, it returns the opposite of each bit. So it'll be, if it's a 1, it'll be 0. It's a 1, it's a 0, and then it's a 1, and then it's a 0, and then a 1. And I see in the chat, yeah, it's 0, 0, 1, 0, 1. Okay, and then let's keep going. So then it'll be or right shift 1, 0, 1, 1, 0, 0. Okay, so next we remember in the order of precedence, we'll evaluate the left circle and the right shift. So remember left circle, it's like in a circle. So we're gonna move 2 to the left, we take off the first 2, and then we add them to the end. So left circle 2 of 0, 1, 1, 0, 0 will be it will be equal to 1, 0, 0, 0, 1, because we took off the first 2 digits and we added them to the end for left circle. And that'll be and 0, 0, 1, 0, 1, or right shift 1, 0, 1, 1, 0, 0. So remember for right shift, we delete the last, so right shift 1, so we'll delete the last digit and then we're gonna add 0 to the front. Because for shift, we always just remove the digits and add 0. We don't, it's not a circle. So then it'll be 0, 0, 1, 1, 0 for right shift 1, 0, 1, 1, 0, 0. Okay, and then according to order of precedence, the and will come first. So and will only return 1 when they're both ones, right? So what will this expression be equal to? Does anybody have any answers? Yeah, 0, 0, 0, 0, 1. That's right. Okay. So then, because the only digit that has both ones is the 5th digit. Okay, so then it'll be 0, 0, 0, 0, 1, or 0, 0, 1, 1, 0. So remember, or returns a 1 if as long as at least one of the digits is 1. So what will the statement, this expression, be equal to? Yeah, 0, 0, 1, 1, 1. Okay. So the answer to this question will be 0, 0, 1, 1, 1, because the last 3 digits all have at least 1 in both of them. Okay, so then let's keep going. So this one is interesting because it's solving for x. So for this one, we're gonna like work backwards, right? So what we're gonna do is we have to solve for this part, and then we know that this one, XOR or exclusive or x, will equal to this one. So if we can find this one, then we'll know this one, exclusive or something, is equal to this one. So then we can find x. So first we have to solve what this expression on the left is. Okay, so following order of operations, we go inside the parentheses first, right here, right? So then it will be right circle 2. So we remove the 2 rightmost digits and we add them to the front. So then this will be left shift 1, 0, 1, 1, 0, 1, or 1, 0, 1, 0, 0, right? Because we took the last 2 digits from the right and we added them to the front. Okay, and then following parentheses, we have to solve for 0, 1, 1, 0, 1, or 1, 0, 1, 0, 0. Okay, so for or, we add the 2, like we make sure that at least one of the digits is 1, right? So then we notice that for the first digit, there's a 1 on this one, so it'll be 1. And then for the second, there's a 1 here, so it'll be 1. And then for the third, they both have 1, so it'll also be 1. And for the fourth, none of them have 1, so it'll be 0. And for the fifth, this one has a 1, so there will be a 1. So it'll be left shift 1 of 1, 1, 1, 0, 1. So for left shift, we take off the lefternmost digit, and then we add a 0 at the end. So it'll be 1, 1, 0, 1, 0, exclusive or x is equal to 1, 0, 1, 1, 0. Okay, so remember the exclusive x, what it does is when I'll draw a table. Sorry. Exclusive will return a 1 only when only one of them is exclusively 1 is 1, right? So if it's 0 and a 0, it'll return 0. And if it's a 1 and a 1, it'll return a 0. So if we know 1 exclusive, so let's just say x is these 5 digits. This one is x. So the first digit of x, exclusive OR with 1, is equal to 1. So then what will x, the first digit, be? Yeah, it's 0, right? Because we know that it has to be exclusively the opposite of 1. Okay, and then exclusive or 1 and something is equal to 0. So then we know it has to be a 1 because if it was 0, then it would equal to 1. And then for 0, 0 exclusive or the third digit is equal to 1. So then this one is also 1, as according to the table. The fourth 1 exclusive or something is equal to 1. So it'll be 0, right? Because it's exclusive, only one of the digits of each is 1. And the last one will be also 0. The last one will be 0, right? Because exclusive or it'll return 0. So that means they have to be the same, basically. Yeah, so the answer is 1, 1, 1, 0, 0. Okay. Are there any questions for this problem? 0. Oh yeah, sorry. X is 0 here because, yeah, it returns a 1. Yeah. Sorry, I saw that wrong. Yeah, the chat is right. So it'll be 0, 1, 1, 0, 0 because the 1 and the 0 will return a 1. Okay, so let's keep going. So the next slide. Okay, so we're evaluating something now. So this one will be basically an order of operations question. Okay. So we have to first evaluate the left circle, right? Because it comes first in order of operations out of this from left to right. So left circle 2, we take off the first 2 and then we add them to the end. So it'll be 1, 0, 1, 0, 1. And then OR, so let's do the right shift 1. So we take off the last digit and then we add 0 to the front. So it'll be 0, 1, 1, 0, 1. And then we'll do and 0, 1, 0, 0, 0. And remember, and comes before or in order of operations. So we'll do, oh yeah, you guys can try it by yourselves because the chat said. So from here, can you guys evaluate this? One, 1, 1, 0, 1. We're getting a couple of different answers. Oh yeah, 1, 1, 1, 0, 1. Sorry, I wasn't sure about the 0, 1, 1. Yeah, so for this one, what we do, right, is we do the and we notice that the only digit where both of them is 1 is the second digit, so it'll be 1 0 1 0 1 or 0 1 0 0 0, and then it will be 1 1 1 0 1. Yeah, because for or only one, at least one, just at least one has to be a 1. Okay, so let's keep going. How did you get 1 1 0 1 0? Sorry. Okay. Yeah. Okay, so let's keep going. So do you guys want to try this problem again on your own? And we'll go over it. Okay, we got our answer 0 1. Okay, so we got a couple of different answers, so let's try this. Oh, one, one, one. Okay, so let's try this one. So left shift 1, it will be 0 1. We take off the last digit, the leftmost digit, and then we add 0 at the end, right? So it's 1 0 1 1 0. And then for right circle, we take off the rightermost digits, and we add them to the front. So it'll be 0 1 0 1 1. And yeah, it will be 5 ones because there's 5 bits in the original one. The answer will always have the same number of bits in the answer as the amount of bits in the problem. Okay, and 0 1 1 1 1. Okay, so we evaluate the and first, so it'll be 1 0 1 1 0, or, and then for the and, it'll only return a 1 if they're both a 1, so it'll be 0 1 0 1 1. And for the or, it'll return a 1 as long as at least 1, so it's 1 1 1 1 1 1 1. And the chat is saying, I'm not sure what the one on the chat is saying, but for these problems, the answer will have the same number of bits. So it'll be 5 ones as the one in the problem, because it's impossible to just delete a bit. So it'll be 5 ones. Okay, so let's keep going to the next problem. Okay, so do you guys want to try this? Or this is kind of a different problem, so I can help go through this. Oh, you want to try it? Actually, since this is a new problem, like a new type of problem, I'll show you guys how to do it first, and then there'll be other kinds of problems like this that we can try later. Okay, so for this one, we set, like, for example, x will make a letter for each digit. So we'll say x is equal to A, B, C, D, E. Okay, so then for left circle 3, we take the last 3 digits and we move them to the front. Or sorry, left are in 3 most digits and we move them and we add them at the right. So then it will be D, E, A, B, C, and 1, 0, 1, 1, 0 is equal to 1, 0, 1, 0, 0. So we notice that for and, it will return a 1 if at least one of the digits is, as long as it will only return a 1 if both of the digits are 1, right? So for the first digit, we see that it's a 1 here. So that means that D has to be a 1, right? Because there's a 1 right here, and D needs to be a 1 in order for there to be a 1 here. So D will be equal to 1. So then let's evaluate what E can be. So we notice that for let's draw the truth table again out for and. For X, Y, X, and Y. So it's 1, 1, 1, 0, 1, 0, 1, 0, 0, and 0, 0, 0. So we notice that if there's either a 0 or 0 and a 1 or a 0 and a 0, both return 0. So since the second digit is a 0, we know that the first one could be either 1 or a 0. So E can be, well, we're going to write an asterisk for E because it has 2 options. So then let's evaluate A. A will be equal to, so we notice that the third digit of this string is 1, and the third digit of this one is 1. So then we know that A has to be equal to 1 because a 1, the only way to return a 1 is if there's 2 1s. So it'll be A is equal to 1. And then for B, we see that it returns a 0, right? And this digit is a 1. So then we know that B has to be a 0 in order to return a 0. Because if B is a 1, then it'll be a 1 and a 1, and there will be a 1 right here. And then lastly, for C, it'll be the same case as E, right? There's a 0 at the end and a 0 right here. So then we see that C can be either 1 or 0 because both 0, 1 and 0, 0 return a 0. So then we'll say C is an asterisk again, right? So then what X is X is equal to 1, 0, asterisk A, B, C, D, 1, asterisk. So there should be 4 choices for bit strings that can make this, right? Because for the asterisk, for these 3 digits, there's only 1 option. But for the asterisk, there's 2 options for each asterisk. So it'll be 2 times 2, which is equal to 4. So does everybody understand that? Yeah, it will be 4. Are there any questions? Uh, no questions? Okay, let's keep going then. So let's clear. Okay, so moving on. Evaluate this one. This one should be pretty easy for you guys. So can you guys try this problem? Okay, since I don't see anything in the chat, I'll show you guys how to do this problem. Okay, so 0 1 0 1 1. Okay, let me see if that's right. Okay, so according to order of operations, we're gonna do not first, right? So it'll be 0 1 0 1 1 or 0 1 1 0 1, right? Because the not returns the opposite each. So 0 is opposite of 1, 0 1 1 0 1. And it'll be and 0 0 0 1 1. So we're gonna do the and before the or because and comes first in order of operations. So it'll be 0 1 0 1 1 or, and it'll only return a 1 if both are 1, right? So it'll be 0 1 0 1 1 or 0 0 0 0 1, right? Because and only returns a 1 if both are 1. Both digits are 1, and these two are not. These two are not. Only the last digit has both as 1. And then for or, it'll return a 1 if at least one digit is 1. So then here, the first one, none of them are 1, so it'll be 0. Second one, the second digit here is 1, so it'll be 0 1 0 1 1. So that will be the answer. Yeah, I see it. Okay, so let's keep going. Okay, evaluate this one. So why don't you guys try this problem? Remember to do the ones in the parentheses first. Parentheses will come before any operator when it comes to order of operations. So you'll evaluate that left shift and left circle and then the right shift and then the not finally. But there are like a lot of different answers, so let's try this to see what's going on. Okay. So, first we do the left circle, right? The left circle, we take off the left and two most digits and we add them to the back. So this one will be equal to 0 1 1 1 0. And then for right shift, we take off the right two digits and then we add 0 to the front, right? So then it'll be 0 0 0 1 1. And then for not, we just do the opposite of the string. So it'll be 1, 1, 1, 0, 0. Yeah, I see. It will be, yeah, 1, 1, 1, 0, 0. So does everybody understand this? Yes? Okay, then let's keep going. Okay, so this one is a
What's the
little,
answer?
sorry, is somebody talking?
What was the answer again?
Um,
The last question?
that one was 1, 1, 1, 0, 0.
Okay.
Okay, so why don't you guys try this problem? One 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 zero zero 11110. Okay, so let's try this problem to see if you guys got it right. Okay, so first we evaluate the ones in the parentheses, right? So right circle 3, we take the rightermost 3 digits and we add them to the front. So it'll be 111. I'm 11, sorry. 11001. Yeah, 111. I'm 11001. And then exclusive or 10111 and 01111, or and then left shift, we take the left and two most digits and we remove them and we add 2 zeros to the end. 10100. So remember, in order of operations, it goes and then exclusive or and then or. So first we're gonna do this one. So then it'll only return 1 if there are 2 ones. So the first one will return 0, the second one will also return 0, the last 3 will return 1. And then we do this with exclusive or 11001. And remember, exclusive or only returns a 1 if there's exclusively 1. So for the first one, it'll be 1. The second one will be 1. The third one, it'll also be 1 because it's a 0 and a 1. Fourth one will also be 1. Only the last one will be a 0, right? Because a 1 and a 1 will return 0, and then it'll be or 10100. So then it will, for or again, we return a 1 if at least one of the digits is a 1, so it'll be 1110. So everybody in the chat got it, so good job. Let's move on. Okay, so identify the actual 5-character bit string that makes the following expression true using the asterisk notation. So this one is a little more complicated, so I'll show you guys how to do this one. So for this one, we're gonna work backwards right here. Then we're also going to evaluate. So first, what we're gonna do is actually evaluate the right expression, because then we can figure out what we want the left side to be equal to. So what will the right expression be equal to? Yeah. So we remove these 4, right? And then we add them to the back, so it'll be 0. Then we add these 3, 0, 0, 1. Yeah, 0, 0, 0, 0, 1. Okay, so that will be what the left side is equal to. So again, let's say x is equal to A, B, C, D, E. So first, let's find what right circle 2 of this is. So we again remove the right twomost digits, and then we add them to the front. So then it'll be 0, 1, 0, 1, 1. And x shifted to the right 1 is equal to this one. So notice that we can actually find what 0, 1, 0, 1, 1 and x is equal to, because we know right shift of this one is equal to this one. So there are actually 2 cases of what this can be. This can be either 0, 0, 0, 1, 0, or 0, 0, 0, 1, 1. Because when we shift to the right, we remove the rightmost digit and we add 0 to the front no matter what. So then we know there are actually 2 cases for what this expression can be equal. Does anybody have any questions about that? No? Okay. So then we can evaluate what x can be equal to. So we've done this before. Let's make our truth table for x, y, x, and y. So again, it'll only return a 1 if the first two, the 2 parts are both 1. So then for 0, so what can x be equal to here? So for 0 and the first digit is equal to 0, it could be 0 or 1, right? Because there's already 1 0, so it'll be asterisk. And then for the second one, for the second digit, 1 1 and x will be equal to 0. So we know x has to be 0, right? Because there's already a 1. And if x was equal to 1, then this one wouldn't be equal to 1, and it wouldn't be equal to any of these expressions. So it'll be 1. I'm sorry, 0. And then 0 and x is equal to 0, so x can be either again. And then 1 and x is equal to 1, so we know x has to be equal to 1, right? Because the only situation where it would be equal to 1 is if x was 1. And then lastly, 1 and x is equal to either 0 or 1, so x again can be an asterisk, right? Because it can be either the result, the output can be either 0 or 1 according to what we did. So then the answer will be asterisk 0 asterisk 1 asterisk. Does anybody have any questions about this? No questions? Okay. Let's keep going then. Okay, so this is another identifying the 5-character bit string. So according to the strategy last time we used, again, we're gonna evaluate what the right side of the equation is first, and then we can figure out what we want it to be. And then we notice that there's another right shift. So then we can basically do opposite like order of operations and do like figure out what this one is equal to according to the right shift. So first let's evaluate left circle 4 of 0, 0, 0, 1, 0 is. So we remove the left or foremost digits and we add them to the end. So it'll be 0, 0, 0, 0, 1. And then we do is equal to this side of the expression. So then we know right shift of this is going to be equal to this. So again, using opposite logic, like backwards logic, we know that it'll be 0, 0, 0, 1, because this one shift to the right is equal to this one, and then it can be either 0 or 1. Again, that's equal to that. Like, do we? I think we I think this one is the same. Yeah, this one is okay. This one is the same problem. So let's keep going. Sorry. Okay, so the next one is another solving for it, but it's a different question. So we already know what the right side is, so we just have to evaluate the left side. Okay, so let's evaluate what we know. We can evaluate this one and this one. And we can evaluate this one, but it will be, let's do this one last because it's the most complicated. So first, we have left shift 1. So we remove the lefternmost digit and we add 0 to the end. So it'll be 0, 1, 1, 1, 0. And then or, let's leave some like a blank thing here and something. And then this one is right circle, not. So the not is 1, 0, 0, 1, 0. And then we circle it to the right? So we take the last 3 digits and we add them to the front. So it'll be and 0, 1, 0, 1, 0 is equal to 0, 1, 1, 1, 0. Okay, so then we find the middle. This part. So let's say x is equal to A, B, C, D, E. What will a right shift do? It'll take off the E, and then it will add 0 to the front. So right shift x is equal to 0, A, B, C, D. And then we left circle 2, so we remove the front 2 digits and we add them to the end. So it'll be B, C, D, 0, A. So that's what this expression is equal to. So then we know we can put it in here. And we know 0, 1, 1, 1, 0, or this one, BCD 0A, and 0, 1, 0, 1, 0 is equal to 0, 1, 1, 1, 0. So according to order of operations, we're going to attempt, this one, we would solve for this one first, and then we would do the or. So we know that we have to figure out what this expression is equal to, and then we can or it with this one to reach this one. But since we can't do that, we're going to work backwards, and we're going to find out what this expression is equal to. So in order to do this, we know that 0, 1, 1, 1, 0, or this expression is equal to 0, 1, 1, 1, 0. So then that means that this expression has to be equal to 0, and then it can be asterisk, it can be anything, asterisk, asterisk, 0. And why is that? Because this is an OR function, right? And OR, it will only return a 0 if there are 2 zeros. So we know that this expression has to be equal to 0 at the front and 0 at the back. And then it can be 0 or 1 because we already know the left side is 1. So no matter what, on both sides, it will return a 1, or is no matter if it's a 0 or 1. Okay. So then we know BCD 0A and 0, 1, 0, 1, 0 is equal to this one. Okay, so then because of the and, we know that if there was, because there's an and, we know that, and there's already a 0 here and a 0 here, B and A can both be equal to anything, right? Because an and, as long as one of the digits is 0, it'll return a 0. And then since the 3 middle digits don't matter, it doesn't matter what they are, C and D are also equal to asterisks. And then E is also an asterisk because it's completely removed from the right shift, so it doesn't matter what E is. So actually, any string will make this equation correct. So the answer will be x is equal to asterisk, 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 asterisk. Does anybody have any questions about this question? E is not a 0. Where we got the 0 from was from the right shift, right? So we had this original string A, B, C, D, E. And then because of the right shift, when we put it into the equation, we removed the E and we add a 0 to the front, so it's 0 B, C, D, A, E. And then we do the left circle. So then E can actually be anything because we're basically removing it from the equation. So then the answer is asterisk, 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 asterisk. Okay, so are there any questions about this question? No. Okay, that's good. Okay, so then let's keep going. Okay. So then let's this one should be an easier question. So can you guys try this question? Remember order of operations, the and comes first and then the or. One. Okay, so let's try. So then this one will be the and, it will be, again, it'll only return a 1 if both digits are 1. So it'll be 0, 1, 0, 0, 1. And then we OR it with 1, 0, 1, 1, 0. So then as long as at least one digit is a 1, it'll return a 1. So it'll be 1, 1, 1, 1, 1. So that will be the answer to this question. Okay. Since it's 7:30, I think that will be all for today. There were a couple questions left, but it's okay. So thank you for coming, and that will be it for today. Okay, bye. Thank you.
Thank you. Bye.
Bye.
Goodbye.